Hello, everyone. Welcome to the next lecture of electronic devices. We are covering chapter number one. And in particular, we are talking about amplifiers. So we are going to continue. So this is lecture number two. Okay. So in this lecture, we are going to talk about another interesting topic related to the amplifiers. And the topic name is amplifier power supplies. Okay, so let me ask you a question. For example, in amplifiers, you can take an example of the speakers. For example, um, we what we are trying to do is we are trying to amplify an input signal. In order to amplify an input signal, this means that the power that is delivered to load is greater than power drawn from input source, right? So we have an input source that we connect to an amplifier. And what that amplifier does is that amplifier amplifies the signal and delivers it to the load. So the power that is delivered to the load is greater than the power that is drawn from the input source. So the question comes, where the extra power comes from? And the answer to this question is, so this extra power does not magically appear from anywhere. What we do is we connect the power supplies to the amplifier, and the amplifier draws the power from those power supplies to amplify the signal. Right, so we connect DC power supplies to amplifier that provides extra power. Excuse me. Okay. So for example, you have also seen that in your speakers, you have to hook those speakers in the AC mains in order to operate those speakers, right? For those speakers to work, for those speakers to amplify the signal, they need power from somewhere. So what we do is our speakers have built-in power supplies in the units where we can connect them to the AC mains, and they convert the AC to the DC signal. We're going to talk about how we can convert the AC to DC in when we're going to cover the diodes. We are going to review in detail how we can build our own power supplies as well. Okay, so coming back to the amplifiers again, amplifiers amplify the signal. It needs more power. That power comes by connecting the DC power supplies to the amplifier. Okay, now let's make that symbol again and how this looks like. All right, so we have again this amplifier symbol, and this was the, for example, if I want to make a common ground, then I can do this. And okay, and what else is here? So we have, this is where our signal VI is connected, and over here we have a load resistance RL, and this is V naught. So how do we bias the power supply, or how do we connect the power supplies? We essentially connect two power supplies. One, we connect a positive, what we call as a positive supply. Another supply that we connect is a negative supply, and this is how it looks like. It is this power supply, and then another power supply connects over here. That goes all the way like this, right? So this is VCC, this is VEE. So the amplifier chips usually have two terminals. One terminal is to connect it to the positive supply, so positive V, and another terminal is to connect to a negative supply, which is a minus V. And this terminal is connected in between here. Okay. Now, so the current that is drawn from this VCC supply is ICC, and the current for this supply is IEE. All right. So our ICC is current drawn from positive supply VCC, and IEE is current drawn from negative supply VEE. Okay. So the power that is, so the DC power or the power that is delivered to this amplifier because of these external power supplies is equals to, so power delivered, DC power delivered, or power delivered to amplifier due to DC power supplies is PDC equals VCC ICC plus VEE IEE. Okay, so there are so this is one power that is delivered to the amplifier. Now we are going to define a few other forms of power. One is the DC power that is delivered to the amplifier because of these external supplies. One power is the power that is delivered to the load. One power is the power drawn from the source. And the fourth one will be the power that is dissipated in the circuit. So let me write down all these four. Okay, so the first one that we saw is the PDC, power delivered to amplifier due to DC supplies. Second is PL, power delivered to the load. Third is PI, is the input power drawn from the source input. And fourth is the P dissipated, which is the power dissipated in amplifier circuit. An example could be the heat. So we have these four types of power that are related to this amplifier circuit. So if I have to determine the efficiency of our amplifier, so we can determine the efficiency of an amplifier by first equating the input and the output power. So our total power is input power should be equal to the output power. So the input powers are two types of power. One is the DC power that is coming from the external supplies, plus the power drawn from the source input. And the output power is the power delivered to the load, plus the power dissipated in the circuit, for example, in the form of heat. Now, interestingly, we know that the power that is drawn from the source is usually negligibly smaller. Similarly, our power dissipated in circuit is also very smaller. So considering this, our main components of the power remains input power as PDC and output power as the load. So if I have to determine power efficiency of my amplifier, it will be approximately equals to output power. Essentially, it will be output power to the input power, right? Input, whatever that input is. In this case, it's the DC power that is coming from the external circuit. So our output power equals to the load power, and input power is equal to the power that is coming from the DC supply into 100%. So this is how you can determine the power efficiency of the amplifier. Okay, so now let's so before what I'm going to do now is we will also do an example that will clear up some of these concepts in more detail, especially related to the power efficiency and some of the concepts that we discussed earlier about the about the different gains of the amplifier. So we're going to shortly do an example. Before I jump to that, I wanted to draw a simple circuit, right? So we just saw this circuit, so I'm going to draw a simpler version of this representation of the amplifier. And you're gonna see that representation throughout the course whenever we are talking about amplifiers. Okay, so this is your amplifier's symbol. You connect this amplifier to the input, Vi, and then you have two VCC. You can also call it as a positive supply, and then you're gonna have a minus VEE, a negative supply. You can call it as a negative supply. And then you are going to have a load resistance, RL. The potential across the load resistance is going to be the output voltage, V0, and again you are going to have a common ground in between the input and the output and the power supplies. The current that is drawn from the VCC is ICC, and over here we have IEE. So this is a simpler representation of the amplifier connected to the external supplies and the input and the output of the load resistance here. Okay, great. Now we will move to an example. In this example, we will see how we can calculate different gain values that we discussed in the last lecture, the voltage gain, current gain, and the power gain. And we will also see how we can determine these different powers that we talked about in today's lecture. Okay, so let me write this example down. Okay, so consider an amplifier operating from plus minus 10 volts power supplies, right? So these plus minus these plus minus 10 volts power supplies are those VCC and VEE supplies, the positive and the negative DC power supplies that the amplifier is connected to. Amplifier is fed with a sinusoid voltage of 1 volt peak and delivers sinusoid voltage of 9 volts peak to 1 kilo ohms load. We get 3 more pieces of information here, right? So 1 volt peak is our input voltage, and our output voltage is a 9 volt peak, right? So I can just see from here 1 volt to 9 volts, the voltage gain is 9, but we are going to formally calculate it shortly. And then our load RL is 1 kilo ohms. Okay, the amplifier draws a current of 9.5 milliampere from DC supplies. Right, so the amplifier draws a current of 9.5 milliamperes from each of DC supplies. So which means that your current values, ICC and IE, that we saw in the last example, or just earlier in the lecture today, so the ICC and IE values are equals to 9.5 milliamperes. Okay, so the input current of amplifier is sinusoid of 0.1 milliamperes peak. We also know the input current, which is 0.1 milliamperes. That is drawn from the source. Okay, so what do we need to find in this? We need to find the value of AV, the voltage gain, the current gain, AI, the power gain, AP. So we need to find all of that. Plus we need to find PDC, which is a power delivered to the amplifier from the power supplies. We need to find the power that is dissipated in the amplifier circuit, and we need to find power efficiency. I'm going to call it like this. We need to find the amplifier efficiency over here. Okay, so let's solve this solution. Okay, so first let's write down all the values that we know. We know the input voltage. Our input voltage peak is 1 volt. We know that our input peak current is over here 0.1 milliamperes. Our output voltage peak is 9 volts. Load resistance is 1 kilo ohms. We saw that ICC, the currents that are drawn from the supplies, DC power supplies, are both equal to 9.5 milliamperes, and we know that our power supplies that are connected are of the same value, which is 10 volts. We know that the VEE is connected in the negative direction to the amplifier. Okay, so with that, let's find out all these values. We need to find out the values of this voltage gains, the power delivered to the amplifier, the power dissipated, and the amplifier efficiency. So we are going to do all of that now. So let's start with the voltage gain. So our voltage gain, we know that it is equals to the input voltage to the output voltage. Our output voltage is 9 volts peak, and input voltage is 1 volt peak. You can also take the RMS and divide that. Ideally you should take the RMS, so divide that by square root 2, which is going to cancel out. So your voltage gain is going to come out to be 9 volts per volts. Okay, now let's find out okay, also another thing that we need to do, we also need to find out, report these numbers in the form of dBs. So in order to report these numbers in the form of dBs, we know that the voltage gain is equals to 20 log of mod of AV. So it should be 20 log of 9. So the answer that will come out for the voltage gain is going to be 19.1 decibels. Okay, so we easily ended up finding the value of the voltage gain of an amplifier. Okay, now second thing down, let's determine is the current gain of an amplifier. So the current gain of an amplifier is the output current to the input current. Do I have an input current? Okay, all right. We already have a value of the input current, 0.1 milliamperes, but we don't have a value of the output current. So let's find the value of the output current first. So I naught. So I naught should be equals to V naught over load resistance. So value of the V naught is 9 volts. Load resistance is 1 kilo ohms. Sorry. it will come out to be 9 milliamperes. After finding the value of I naught, now we can easily find out the value of the current gain. I naught is I naught over II, so I naught is 9 milliamperes, and II, the input current, equals to, what's the value of the input current? Input current is over here, 0.1 milliamperes. So the value that we ended up finding is 90 amperes over amperes. We can also report that in the terms of sorry. Yeah, we can also report that in the terms of decibels. So it would be 20 log of 90. 20 log of 90 is going to come out to be 39.1 decibels. So we ended up finding the value of the current gain as well. So the things that are left now is to determine the value of the power gain, the other powers, the dissipated power, the DC power, and the power efficiency. Okay, so let's go and find the value of the power gain. Okay, our third thing that we want to determine is the value of the power gain. If you remember, we derived the equations in the last lecture. The power gain is a product of the voltage gain and the current gain. Right, so if I go back here, I know that the voltage gain equals 9 and the current gain equals 90. So I can do 9 into 90 equals 810 watts per watts. I can also convert that into decibels by doing 10 log of 810. It comes out to be 29.1 decibels. Okay, great. So this is how we ended up determining the power gain as well. Now going back, what's the next thing that we want to determine? The next thing that we want to determine is the PDC. The PDC is the power that is delivered to the amplifier by the external power supplies. And earlier we derived an equation for that. We said that PDC equals VCC ICC plus VEE IEE. And we saw that actually VCC is 10 volts, ICC is 9.5 milliamperes plus 10 volts into 9.5 milliamperes. So the answer is, if you are going to multiply this thing, the answer is going to come out to be, we can also solve it very quickly. 9.5, 95 plus 95, 95 milli plus 95 milli is going to be 190 milliwatts. 190 milliwatts is the value of the power that is delivered from the external power supplies to the amplifier. Okay, so we are done with this. The other thing that we need to determine now is the dissipated power. Now we need to determine the P dissipated. Before we determine the P dissipated, so let's see how we can determine P dissipated. P dissipated. From the equations, you remember that the input powers is equal to the output powers. Right, so I can use this equation to determine P dissipated. I already know this value. This is what I want to determine. The other two, let's find out the other two values. Let's first determine the value of the PI and PL. And then we can put in those values and find out the value of the power that is dissipated in the circuit. Okay, so let's determine PI first. So the input power that is drawn from the source, it should be equals to VIII, right? And whenever we are talking in terms of a power, we need to take again the RMS value. So it will be VI RMS multiplied by, this is II RMS value. So it will be, input value was 1 volt peaks, so RMS is going to be 1 over square root 2, and input current was 0.1 milliamperes. So divided by square root 2. So the answer that is going to come out to be for the input power drawn from the source is 0.05 milliwatts. Okay, now let's determine the value of the load power. So the load power is again very similar. It's the output RMS voltage multiplied the output current RMS. The output voltage RMS, if I will go back, we can see here's the output voltage RMS, 9 volts, and here is the output current we determined over here, 9 milliamperes. And we need to take RMS, so it will be 9 over square root 2 multiplied by 9 over square root 2. So the answer is going to come out to be 40.5 milliwatts. So we ended up determining the values of PI and PL. Let's put down these two values here. So our power dissipated equals PDC plus PI minus PL. PDC is 190 milliwatts plus PI is 0.05 milliwatts. And the load power comes out to be minus 40.5 milliwatts. The answer for that comes out to be 149.6 milliwatt for the value of the power dissipated. Actually, if you look at this number, this is actually quite a high power that is dissipated in the form of heat or other factors in the amplifier circuit. Okay, our last thing that we need to determine now is the efficiency, power efficiency of the amplifier. Now we know that our power efficiency equals to the load power that is delivered to the power that is supplied. So the load and multiplied by 100, of course. So the load power that is delivered was 40.5 milliwatts divided by the power that is supplied from the from the DC supplies is 190 milliwatts. So if you're going to multiply that, your efficiency is going to come out to be 21.3%. Right? So this was the percentage efficiency of your amplifier. Okay, so this is the end of today's lecture. What we discussed in today's lecture is we started with this basic concept that when our amplifier is amplifying the signal, meaning that it is supplying more power to the load rather than what is being drawn from the source, so where that extra power is coming from, we use these external DC power supplies to make that happen. Then we did this power analysis where we say that we have these 4 kinds of power. One power is being delivered to this amplifier from the supplies. Another one is going to the load. Another one is coming from the input source. Another one is being dissipated in the heat. So we write down these equations. This equation is important in solving some of these problems. We also determine the value of the power efficiency of the amplifier. This was the most simplest representation of the amplifier that is powered by the DC power supplies. After that, we did one example in which we determined the values of the voltage gain, current gain, and the power gain, and we use this formula of the power to calculate the values of the power that is delivered to the amplifier from the DC supplies, that is the power that is dissipated in the circuit, and we also determine the power efficiency. Okay, so with that is the end of this lecture. For this week, we have another small lecture before we wrap up this week. I will talk to you guys in the next lecture now. All right, thank you so much. Have a great day, and bye-bye.